Good afternoon, everybody. This is a live update on the tornado threat that right now is increasing across northern Alabama into central Tennessee. And right now we are watching a severe thunderstorm warning. It is still quite a ways to the south of Huntsville. And a little bit ago I was more interested in this storm, but it does seem to be getting a little bit less organized. It's trying to merge with some new updrafts off to its right. But there is a tornado watch that has been issued for this region across northern Alabama into central Tennessee. This storm here did have quite a bit more rotation earlier on. I'll do the long loop here on this app, and you can see it get isolated right there. Turn to the right, and then some of that new convection out toward Union Grove here started to impede some of its inflow from the southeast, but the main parent supercell is still in there, chugging away, and it does have some deviant motion moving a little bit more off to the northeast. Any of these storms that are able to develop deviant motion and can move off to the northeast, those will be able to enhance the storm relative wind shear available to those. You can see that some of the lower cloud elements are moving from southeast to northwest, whereas the mature, deeper supercells like this one that we're watching to the south of Huntsville, this one's moving a little bit more north-northeast, maybe even northeast at times. You can see a little bit there just to the east of Eva, to the northwest of Arab. Looks like it did try to wrap up and turn east there, right on approach to the west of Union Grove Union Grove area, south of New Hope as well. But this storm is packing some pretty strong winds. I did think it had tornado potential right there, but now with these storms moving off into its inflow from the southeast, it is starting to disorganize this supercell just a little bit. But usually the supercell storms are able to win out, and they'll continue to progress northeast, and then they could potentially become tornadic when they're able to carve out little rain-free areas of inflow in there. But it does look like there's another area of precipitation that is approaching from the southeast. But as I mentioned, there is a tornado watch in effect for this area, and it goes all the way up to near Nashville, at least the southern side of Nashville. It might even include downtown Nashville as well. Looking off to the south, there is some isolated convective development down through the Birmingham area as well. We'll keep an eye on those. There's the initiating boundary. You can really see it well on radar. And in fact, there's multiple initiating boundaries here ahead of this upper level low. Even some isolated storms developing just to the north of Tuscaloosa. Some stronger storms on the west side of Birmingham. Maybe a little transient supercell structure here to the west of Kimberly, just to the northwest of Birmingham. That could be something to watch. You do kind of have this tight gradient here on the southeast side of that system. And it looks like these storms, as they're developing, do have some supercellular characteristics. They have these little miniature hook-like appendages on the southwest side of them. You can see another one here just to the southeast of Sylvan Springs, northwest of Fairfield. And if any of these are able to clean out some good clean inflow for even 20 minutes, 30 minutes or so, and they can quickly become tornadic and tighten up at the lower levels. I'm watching this area here, a little bit of a concave, tight gradient to the reflectivity there on the southern side of that storm. You can see some embedded hooks in here, multiple supercells as they're developing. Let's take a look at velocity again and see which ones are rotating. This one that we were watching definitely is trying to mature a mesocyclone to the west of Kimberly. Let's shorten the length of that just a little bit. A couple of mesocyclones up there to the northwest of Kimberly, and any of these that are able to turn off to the northeast will have a greater chance of tornadoes. There is some decent rotation to the northwest of Warrior up there as well. And you can really see these convergent boundaries, these initiating boundaries that are developing these storms. This is ahead of an upper level low that even is a little bit detached from the jet stream, but still very capable of producing tornadoes, almost like an MCV or a dying tropical system. But in this case, it definitely has a cold core, upper level low. Some flash flood warnings as well out here in eastern Tennessee. Some higher terrain there, definitely flash flood prone. Dunlop up toward Spencer in eastern Tennessee. These storms, though, this one that prompted this live definitely does have some convection interfering with it just off to the southeast, and then another area of some strong convection closer to New Hope. So they're definitely preventing this parent storm from going tornadic. It looked like it was able to carve out some clean inflow there for several minutes, almost became tornadic, and now its inflow is definitely getting impeded, and that's definitely going to be a limiting factor for tornadoes throughout today. It's just this widespread convective initiation out here, and storms impeding the inflow of others, disrupting their structural evolution, preventing what would be a tornadic supercell from becoming tornadic. And sometimes that can happen. Those are mesoscale accidents that can work out the other way, except those are to be expected on days like this. Lots of storm interaction being expected. So let's now break down the environment that these are embedded within. And I apologize for this camera. It does make my skin look a little bit red and flushed. It's really not like that. I use a lot of facial lotions and stuff. So, but yeah, this camera definitely makes my face look bright red, like I'm flipping out. But I'm actually really calm right now. Let's switch on over to the internet so we can break down some of the environmental conditions that these storms are in and what prompted that tornado warning, which is in effect through the afternoon, northern Alabama and into central Tennessee. And those storms that we're monitoring that do have the severe thunderstorm warnings to the south of Huntsville, those should continue off to the north with those meridional storm motions taking them eventually into central Tennessee. So here is the tornado watch. And it is in effect until 10 p.m. Central Time. Let me make sure I'm switching slides here, folks. Getting used to working this new laptop. But this thing should be able to survive an F5. If I'm using the internet, surfing the internet, and I'm using this Dell Toughbook inside of a tornado, there's a very good chance that the Toughbook will survive and I will not. But of course, I'll be able to escape. I always have multiple escape routes if I'm not in the Dominator. If I am in the Dominator, then we'll just deploy the spikes, dominate the storm. So there you can see the tornado watch. It actually does include a fraction there of northwestern Georgia. Pretty decent probabilities, though, for that for tornadoes within this watch. So let's try to find a better region here that centers on our tornado watch area. There we go. So you can definitely see the belt of easterly winds there at the surface. Let's first look at surface-based Cape. An abundance of Cape here, near 3,000 Cape, 2,000 to 3,000 surface-based Cape. And look at these easterly surface winds as well. That makes it possible to squeeze out more bulk shear between 0 and 6 kilometers. You've got about 40 knots out of the south or even the south-southwest, especially as you go from central Alabama down to the south. But these winds should be veering with time aloft as well, which will help to enhance the storm relative helicity, as will any right movers. So any storms that are able to move due northeast, I think will also be able to squeeze out quite a bit more storm relative helicity out of this. As it is, you have about 100, on the order of 100, 0 to 1 kilometer shear. Relatively modest low-level jet here out of the southeast at about 15 knots. That's underneath about 40 knots out of the due south or even the south-southwest. So there is enough bulk shear for supercell storms. Low-level shear, though, is a little bit lacking, and we forecast out with time. And look at all those supercells develop across northern Alabama into central and eastern Tennessee. Those areas that already do have flash flood warnings in eastern Tennessee are going to have even more rain as we go through sunset and into the evening hours. Storms probably training over each other there in eastern Tennessee. So those areas in flash flood warnings and the surrounding areas in eastern Tennessee certainly could see an increase big time in your flash flood potential. And look at those clusters of supercells there developing across northern Alabama. But basically you've got about 100 to $125 0 to 1 kilometer storm relative helicity, which is borderline for tornadoes. And that's probably why these storms aren't just tightening up all over the place. But these upper level lows that already have pre-existing background spin in the atmosphere, cold pocket of air aloft across the Mid-South, they're notorious for having tornado potential. And you do have this area here of about 0 to 2, 0 to 3 kilometer EHI. Pretty decent EHI out here. As you can see, this swath here in the northeastern quadrant of that upper level low. And it's actually the eastern quadrant of that upper level low. There's the cold pocket of air, minus 15 at 500 here, spinning right over top of Memphis, Tennessee. So that's why you have all this cape out here. Definitely a fall type of a system, a changing of the seasons type of a system with a bowling ball of cold air aloft here. You have these easterly winds at the surface. Some convergent boundaries are also evident here, even within the RAP analysis, and you can definitely see them on radar, these convergent boundaries of supercell storms developing. So basically the tornado watch area covers this area with 1,500 to 3,000 Cape and about 100 to 125 0 to 1 kilometer helicity. And it's not getting any stronger with time either. Usually you have to watch out with those environments. When you have a low-level jet, for example, that's increasing with time, low-level shear that's increasing as you go towards sunset in the overnight hours. That also means that this is probably going to be an event that's very diurnally dependent. You really require that surface heating beneath the bowling ball of cold air aloft. Go to our favorite model. Definitely see that. 18Z, 3 kilometer NAM. You can see all those storms developing there. Let me make this a little bit smaller so everybody can see it. Looking back at radar at the same time to make sure we don't miss any red boxes. So here you can see that upper level low. Here's spinning away at 500 millibars, a bowling ball of cold air aloft here. Decent flow downstream. And you especially get some decent shear where you get these more southwesterly mid-level winds out here, where they're more southwest to northeast. You really are dependent on these easterly surface winds as well, with more meridional or south to north moving storms. But here's your environment. Definitely some non-zero, 0 to 3 kilometer EHIs, showing you that co-location here of surface-based Cape. Quite a bit of Cape out there, 2,500 to 3,000 Cape. You're probably going to be talking about quite a few hail reports out here with this as well. Looking at weird photographs, definitely weird photographs, almost like the northeastern quadrant of a tropical system, but definitely very profiles that are very prone to hail here, with a lot of bulk shear, greater than about 40 knots. And you can definitely see the mid-level dry slot there, elevated mix layer, mid-levels of the atmosphere. You can see that trying to steepen those lapse rates. You definitely need more strong easterlies, though, to really carve out a photograph with a lot of 0 to 1 kilometer storm relative helicity. So even though you get very steep lapse rates, very favorable thermodynamics here. The 0 to 1 kilometer storm relative helicity, the low-level shear, that's very important for tornadoes, is relatively lacking at 20Z here. But you can see that you're at least getting 0 to 1 kilometer shear in excess of 100 pockets of it. And it's actually greater up across central Tennessee, central eastern Tennessee up there. You're even getting a little bit closer to 150. Probably enhanced by some of the rain-cooled air up further north into central Tennessee as well. But you definitely do get supercell storms. Kind of what we're getting right now, these clustered modes of supercells, but you'll get a lot of cell interactions, a lot of impedance of storm inflow, but it does look like these supercell storms here. The HRRR certainly does have a decent handle on this as you're going through the afternoon. Clusters of these supercell storms moving through central northern Alabama, multiple waves up into central Tennessee as well by 22Z, 5 p.m. A lot of rain, too, starting to train over some of these flash flood warnings out into eastern Tennessee, so keep an eye out on that. Definitely flash flood threat is even greater than the tornado threat with these. And this is as we're getting closer to sunset, 7 p.m. Central Time, an hour or two before sunset out here. You've got clusters of transient supercell structures, heavy rainmakers as well out there moving into central Tennessee, northeastern Alabama. Maybe eventually into northwestern Alabama late, but I'm not really seeing any near-term tornado threat yet that's going to evolve yet. It looks like the HRRR hints at development of some renegade storms down there after sunset. These could be a little bit elevated across northeastern Alabama, northwestern Georgia as well. But there is decent bulk shear out there, so I do expect supercell structures across northern Alabama. Southwest to northeast winds, about 30 to 40 knots as well, creating plenty of bulk shear down in that area. And it's possible that even that low-level wind shear could increase just a bit down south, increasing that tornado threat. You look at some forecast soundings down near the Chattanooga area. They do get more favorable when you get after sunset. You get the 1 kilometer wind increasing over about 30 knots. And you get these easterlies here, quite a bit of wind there in the easterlies of that section of that hodograph. And you do have that strong elevated mixed layer though. But you do have a nocturnal inversion that develops right near the surface. You can see that red line nosing down, a little bit of cooling near the surface that could cause these supercells to be a little bit elevated, but they do get a little bit more favorable as we get towards 7 or 8 p.m. Within this environment here. Southeastern Tennessee, northeastern Alabama, northwestern Georgia as well, just to the east of that upper low. That's at 2Z right there, so about 8, 9 p.m., 7 to 9 p.m. And this tornado watch does go until 10 p.m., kind of going by the HRRR with these storms sustaining and even intensifying there in northwestern Georgia, northern Alabama. They do seem to run out of steam a little bit into central Tennessee, probably losing some of the favorable low-level thermodynamics. The models do hint at a cluster of renegades developing down into central Alabama late to 7 to 10 p.m. out there. So I do think that there is a chance of tornadoes here. Northwestern Georgia, central Tennessee, northeastern Alabama. Still looks like supercells continuing even after about 11 p.m. Might need a continuance of that tornado watch. I am seeing a flash flood threat that could increase as well here across eastern Tennessee, maybe even down into northwestern Georgia. Round after round here of storms training over the same area here. So you're going to get a lot more rain, and there's already some flash flood warnings out there. So let's go back to the real-time radar really quick and see how some of these storms are doing. We were watching that storm with a severe thunderstorm warning just to the south of Huntsville, but it does look like that severe thunderstorm warning has been dropped. Or is this a little further south? Yeah, that's further south. Going back off to the north. Still a severe thunderstorm warning for that storm to the south of Huntsville. There's Huntsville. That's supercell originally right here. Had a lot of convection here interfering it with its inflow, which is out of the due east. So anytime you're getting a storm immediately east of one, like these are, it'll decrease the tornado potential of that storm just to the northwest of New Hope here. Further down the line, we could watch for some supercell development down near Guntersville, Sneed. But I am watching this one relatively closely down in closer to central Alabama. It's trying to develop a little hook-like appendage, but it doesn't really have that proper structure yet. Those photographs are a little bit weird. Not a ton of streamwise vorticity available to these storms until they turn off to the right, to the northeast. So you're probably going to get splitting supercells with an equal favoring of the left and right mover there. But you can definitely see these initiating boundaries on radar, convergent lines there that could lead to the formation of additional supercell storms. And we'll just keep watching it. That tornado watch is in effect until 10 p.m. These areas that have flash flood warnings, keep an eye out. Definitely a lot more rain on the way, it looks like, through this evening. Already some flash flooding reported by law enforcement, between 1 and 3 inches of rain falling over a short amount of time. Probably some warm rain processes out here too with these storms, meaning that there's probably some pretty heavy rainfall rates. Although you do have a lot of cape out there and a pretty strong elevated mix layer, so I do think that if some of these supercells can get isolated a little bit, especially when you're closer to that pocket of about minus 14 to minus 15 degrees Celsius aloft in the mid-levels of the troposphere, I do think you can get some good hail cores out of this, including just north of Birmingham. Probably about to see some severe thunderstorm warnings being issued for these. This radar site here in Birmingham is scanning pretty high up in this storm too, so you're really picking out those hail cores within this storm. Damn horseflies trying to lay eggs on me in here, I think. So there you can see some of those hail cores back toward the Sipsey area, north of Willow Grove, west of Sloan. Could get some, you're probably already getting severe hail with those storms, especially given such steep mid-level lapse rates. Abundant bulk shear as well, especially. And you've already got these flash flood warnings all over the place. But looks like the heaviest rain is heading back up, where you're already got these flash flood warnings for eastern Tennessee, and you've still got very heavy rain across the northern portion of these flash flood warnings, north of Chattanooga. But probably going to get a lot of these messy modes, and it's going to be difficult for any of these storms to carve out any clean inflow. The exception being maybe a little bit further south, but the wind shear isn't quite as strong down there. Although if you can get these storms moving off one of these initiating convergent boundaries, then I think maybe further south could even have a slightly higher tornado potential down between Birmingham and Huntsville area, spreading into northwestern Georgia, and then eventually central Tennessee as well, bringing with it increased flash flood potential as well. So I'm going to keep a close eye on this, and my storm chase mode is activating on Sunday across Tornado Alley. Southern Plains look like they're going to be going nuts. So I'll be live streaming out there Sunday, Tuesday, Wednesday, chasing the central U.S. Textbook dry line setups. So definitely stay tuned. And also stay tuned to Storm Rising, which airs every Sunday at 10 p.m. Eastern, 9 p.m. Central. National Geographic Channel every Sunday. Our second episode is coming up this Sunday, which features high plains insanity, big time hail shattering the windows, tornadoes climbing up the western slope of the Black Hills, you name it, it'll be on there. But here is just an absolute cluster, mass chaos here of storms with that tornado threat definitely decreasing dramatically. Huntsville and off to the southeast, which is the main reason that I was going to go live. So that's good news out there. Short-term tornado potential decreasing across far northern Alabama. But I am watching some of these more isolated storms down towards Sipsey, just to the north of Birmingham, that could develop short-term tornado potential as well. Looking at more optimal radar site. They're kind of losing their supercell structures too, so not too terribly worried about those storms either. But definitely stay tuned. I'll be going live if this tornado threat ramps up to the east of this upper level low. Never stop chasing.